What's up? All right, section 6, number 2, take 3. We're going to use IVT to show that f of x equals 3x minus 6 and g of x equals negative 5x cubed has at least one intersection on the interval from 0 to 2. So IVT tells us that in a function, when you have one point going towards another, there is a certain set of values within the interval from the 2 points that the function has to cross in order for it to even reach that point. You can draw the graph however you want, but we know that it has to touch, has to pass every one of these y values in order for it to reach this value, if the function is fully continuous, which in this case, looking at what we have, what functions we're working with, there are no restrictions for what the y value can be. These are all fully continuous functions. And even when we combine them, f of x, we're going to turn them into h of x by saying that f of x is equal to g of x somewhere on the interval of 0 to 2, meaning if you have two of the same values and you subtract them from each other, it should equal 0. So our h of x is going to be equal to f of x, which is 3x minus 6, minus g of x, so minus negative 5x cubed. So just rewrite this to make it look a little bit more satisfying. That is 5x cubed plus 3x minus 6, which has to equal 0 at some point between 0 and 2. So we're gonna use IVT to prove that it has to equal 0 at least one time on the interval. So if we look at h of x from the top of the interval, that is furthest to the right, h of 2, it's gonna equal 5 times 2 cubed plus 3 times 2 minus 6. And that is equal to 5 times 8, 40, plus 6 minus 6, which is equal to just 40. And then h of 0 is equal to 5 times 0 cubed plus 3 times 0 minus 6. Anything times 0, 0. So we have negative 6. So from 0 to 2, h of x goes from 40 to negative 6. Let me just sort of organize this a little bit better. Domain 0 to 2, range 40 to negative, well, I'm going to do negative 6 first. Negative 6 to 40. And as you can see with these corresponding values, somewhere from 0 to 2, let's just keep it like this. At 2, this line is going to equal negative 40, that is 2 comma 40. And at 0, whoops, wow, that was really bad. 2 comma 40, which is going to be way up here. 2 comma 40, and 0, negative 6. Let's say negative 6 is right here. As you can see, you can even draw this however you'd like, but there's this little box that the function containing the y values that the function has to touch for it to even, wow, that was the wrong point. It's actually this one, my bad. It is from this point that it passes 0 somewhere. Somewhere, however, this function may look, it's going to pass 0. So, because we know that h of x passes 0 at some point, we know that the function f of x and g of x will intersect at least once throughout this interval.